This lecture is part of an online course of Calculus 1, and I'm going to talk about essential classes of functions. Why do we classify functions? It's just because we want to have a mathematical model. What do I mean by that? Mathematical model. What is that? It's a mathematical description of a real world phenomena. Well, mathematical descriptions are like what? They are like equations or functions. So we use equations, we use functions to basically describe, for example, a real world phenomenon like the size of a population, of a city or a country, or we can talk about a demand for a product. We can use mathematical description to find the speed of a falling object. The speed of a falling object. So basically these are real world phenomena, and we use equations, we use functions to describe them. That's why we need to be familiar with all types of essential functions, because we want to use them in mathematical models. So what are the essential functions that we are going to study? One of them would be linear functions. The other one would be like polynomials. Then we are going to talk about algebraic functions, which basically are functions that can be constructed using addition, subtraction, fraction, square roots of polynomials. Or we also have transcendental functions. These functions are not cannot be described using polynomials. Okay, so there are like trigonometric functions, logarithmic functions, etc. Okay, so let me start by linear functions in this video. So linear functions, this is basically the first class of essential function that we are going to study. It means that we have no exponent on variables. We don't have any fractions on variables. We don't have variables on the denominator. So we have some nice functions. So for example, they could be like f of x equals to ax plus b, where a and b are just some numbers, some constant, and x is just the variable. So this is called one variable function. And the one variable is just the variable x, and as I said, a and b are just numbers. So what is that? It is a line in xy plane. So this line has the slope a, and then b would be y-intercept. Okay, so let me graph a line. This is x-axis, this is y-axis. Let me have just, for example, one line like this. Okay, This is y equals to ax plus b. So the slope of this line is equal to a, and then y-intercept, by y-intercept I mean the intersection of the line with y-axis. Okay, so basically for this line in here, if I said x equals to 0, I get y equals to b, and so b here, which is the distance from the origin to the point B, this is my y-intercept. Okay, so now if we have just one line, I'm just gonna give you a recall from before. If this line passes through 2 points, x1, y1, and the other point x2, y2, then slope of this line, which I call this line L, slope would be what? Slope, we usually show it by M. Here I show it by A. We usually show it by M, and it is basically a fraction, which is y2 minus y1 over x2 minus x1, which is basically the change in y's over the change in x's. Okay, so for example, if the line passes through 2 points, just say 1, 2, and then another point 4, 5, and for example 10, then the slope of this line would be what? 10 minus 2 over 5 minus 1, which is equal to 8 over 4, which is equal to 2. Slope of this line in here is 2. Okay, now if you're given a slope and a point, the slope and a point of a line, then equation of the line L with slope that is equal to m, that is passing through the point x1, y1 is equal to what? Just as a recall, it would be y minus y1 equals to m, the slope x minus x1. So basically y and x here, this y and this x in here, they are just variables. Okay, and then you're gonna put the coordinates of your given point, the first coordinate in here, second coordinate here. So in these two spots you have numbers, and the slope is just a number. Okay, that was basically a recall of how to find equation of a line. Okay, let me give you one small note, is that if you have more than one variable, you see, and here a linear function with one variable is just a line ax plus b. If you have more than one variable, just assume that you have 3 variables. Okay, then what is the equation of your linear function? So I'm gonna say with more than one variable, then for example, just assume that you have 3 variables, something like that. 2x plus 5y plus 8z is equal to 10. What is that? It has 3 variables, and as you see, it's a linear function because you don't have any exponent on the variables, not negative exponents, not fractions, not even positive exponent, nothing. So it's a linear function, and it is basically a plane. It's a plane in 3 dimensional space. Let me show it to you. So as you see, we are in three-dimensional space, and instead of just two axes, we have three axes, x, y, and then the axis z. And the equation of our linear function was 2x plus 5y plus 8z equals to 10. And as you see, it's a plane in three-dimensional spaces. It's this plane. Good. On the next video, we're going to talk about polynomials.